In this module, we're going to look at solving, graphing, and answering in interval notation for compound inequalities. And so in compound inequalities, we have two different types. We can have an and inequality, and then we can have an or inequality. And so I've got kind of some key ideas here for both. In an and inequality, you want to make sure that your solution satisfies both conditions. That's really important. And you want to think of it as the overlap when you're looking at the graph. And so when you're graphing it, you're going to look for where they intersect. So the two parts, they can intersect. For your interval, it's going to be the part that satisfies both inequalities. Then the difference in that and the or, in the or, it can satisfy either condition. So one or the other, or it could be both. The graph, you're going to include all of your values from both inequalities. And for your interval, you're going to combine it into a union of sets. So again, pause the video and make sure you write those down. So let's look at some examples. We're going to solve these just like in an equation. The only difference is sometimes it's like having two equations. And so the first one is an and inequality, and you can see that because it's got the word and in it. We're going to solve it like it's two different inequalities. So I'm going to start by dividing this first one by 9. And when I do that, I get x is less than 5. I'm going to drop that word and right down. That's part of my solution. And then here I'm going to subtract 9 from both sides. And I get x is greater than -1. And so my solution as an inequality is right there. Now I can go to my graph and I can graph these. So the and has to be the overlap. It has to be in both situations. So when I graph these, I'm going to color code those. So I'm going to graph the first one in purple. So this would be my purple graph. I don't like how that is. That way it kind of looks like it was or equal to. So let's do it that way. So I'm going to go to 5. I'm going to have an open circle. Okay. I'm going to do this above the graph. And I'm going to shade everything less than that. All right. So we're going this way. Then I'm going to come over here to this one, make that one blue. And I'm going to graph at -1. I've also got an open circle. This time I'm going to shade everything that is bigger. So for and inequalities, we're looking for the overlap of these two things. And so right here, this is where my solutions fall in both x less than 5 and x greater than -1. And so the only part that's actually in my solution is going to be from here to here. All of this. But if you notice, I kept them as open circles because this part here is not in both. It's only in the purple. And this part here is not in both. It's only in the blue. So I kept those open circles. Now, as an interval, again, remember we're only using the part that's on the actual number line for my answer. So my interval starts right here at -1. And it's an open circle, so it's a parentheses. The shaded part is a comma. And then I've got an interval that stops at 5. And it's open, so it's another parentheses. Okay. All right, example 2, we've got another and. So we're going to solve them separately. We're going to do -5. And then I've got x is less than -2. I'm going to drop that and then I'm going to divide by -5. And remember, when we divide by negative, we have to flip that inequality. So it went from being less than to greater than -1. So this is my solution as an inequality. So I'm going to come down here and I'm going to graph on the same way. So I'm going to graph this one in purple above my graph. So -2, okay, open, to the left because it's less. Then I'm going to graph a -1. I am open, and I'm going to the right. Now, this is an and inequality, so I've got to find where they overlap. But if I look at this graph, there is no overlap at all. So since there is no overlap, there is nowhere that both of these things are together. There's no solution that falls into both categories. So what that means is the answer is no solution. There's no place that both of these are going to be true. So for your answer, you would simply put no solution. Okay. Example 3. So this is an and inequality. When you have and inequalities, you can also write those as compound statements like this one. And so when you're solving them, you're going to do whatever you do to one part to all three parts. So to solve this one, I'm going to still try to isolate this variable here. And to do that, I'm going to start by subtracting 3 on both sides. And that will get rid of the 3 here. It will give me a -35. I'm going to drop down that inequality. I've got -5c in the middle. And then I'm going to get rid of that 3 because it's gone. I'm going to drop down that less than. And then I've got -20 on the right. Now I can divide by -5 to isolate that c, and I need to do it in all 3 places. Now remember, when we divide by a negative, that means you have to flip those inequalities. So when I do that, I've got 7. I'm going to flip that and make it greater than or equal to. I've got c. I'm going to flip that one and make it greater than 4. And so what this is actually saying is that I've got 2 different statements here. I've got this one, which is saying that c is less than or equal to 7. Notice how I flipped that so that it's still pointing to the c and opening to the 7. And c is greater than 4. So you can think of it as 2 different statements if you want to, okay? Or you can think of it as saying, okay, this is all the values of c that are between 4 and 7, or between 7 and 4. So on my graph, what's happening here is I've got an open circle here, or sorry, closed circle here at 7. I was going to do it the other way. Closed. And we're going all the values that are less than 7. And then I've got an open circle on 4. And I've got all the values that are greater than 4. And so if we're looking for this value that overlaps, we're looking right there. And so what happens for my solution is you can see it ends up being all these values where it's between 4 and 7, just like you can see here in our solution. And that's exactly where you graph. And you can notice that one circle is open, one circle is closed, and that's absolutely okay. That happens. It just means that the 4 is not included, but the 7 is. And so when you write your answer in interval notation, you also need to make sure that you have a parentheses with the 4, since that one's open, a bracket with the 7, since that one is closed. Example 4. This is an or statement. So we're still going to solve them the same way. We're going to start out by, I, again, like to have all of my x's on the left. That's just a preference. So I'm going to subtract that 2x over. Okay, and so that's going to give me 4x. I'm also going to add that 4. Okay, so I'm going to subtract that 2x. I'm going to add that 4 to the other side, because that's going to make this go away. It's going to make this go away. And so I end up with 4x is less than 4. Then I can divide both sides by 4. Since it's not negative, we don't have to flip it. So x is less than 1. Now, just like with the and, I'm going to drop that or down. Then I'm going to do the same thing here. So I can divide by -2, divide by -2, and x is, flip this, since we divided by a negative, greater than or equal to 3. And so this would be my inequality answer. Now, to graph this, for an or statement, it just needs to be in one or the other or both. So I'm going to go and we'll graph this one. So 1, it is open and to the left. And then 3 is closed and to the right. And for or, they do not need to overlap. You're going to shade and keep everything. And so when you're writing your interval notation for this one, we're going to start at the very left, which is -infinity. We're stopping at 1, and that's an open circle, so it's a parentheses. If you jump from one section to the other, you have to group those together, and the union of those two groups you're going to represent with a U, a capital U. And then we're starting back over at the 3 with a bracket since it's closed. And then all that shaded area is going to be with the comma, and then we're ending up with positive infinity. And that's our interval notation for example 4. Last example. So again, we're going to solve each of these separately. Okay, so I'm going to subtract that 1. So I've got -7x greater than or equal to 14. I'm going to divide by -7. Since I'm dividing by a negative, we got to flip that inequality. I'm going to bring down that or sign. I'm going to subtract 3 on this one. So 6x is greater than or equal to -24. I'm going to divide by 6. And then x is greater than or equal to -4. I did not need to flip the inequality in that one because I divided by a positive number. And that's my inequality. Now I'm going to graph it. So it's an or, so there it can overlap. So I'm at -2. I'm going to put my closed, and I'm going this way. Okay. And then at -4, okay, this is kind of weird, but that's okay. Let's see what happens. I've got a closed circle, and I'm going this way. Well, what do you notice happened here? They overlap completely, and everything is shaded, and that is okay. What ends up happening is my entire graph is shaded, every single value, and that's okay. That just means that my solution is all real numbers because everything is shaded. And so sometimes you can get all real numbers, just like sometimes you can get no numbers and no solution. And to write that as an interval, it's just shaded from -infinity all the way to positive infinity. So -infinity to positive infinity would be our interval.